Hello everyone. We will be learning about writing and balancing the chemical equations in this video. The contents in this topic are 1. What is a chemical equation? 2. Parts of a chemical equation. 3. Writing chemical equations. 4. What are balanced equations? And 5. Balancing chemical equation with examples. What is a chemical equation? A chemical equation is a mathematical representation which symbolizes the product formation from reactants. Here, A plus B gives C. A and B are reactants that are on the left side. C is the product which is formed on the right side. The following equation states 2H2 plus O2 gives 2H2O. Let's understand the parts of a chemical equation with an example. Sodium and chlorine yield sodium chloride. The reactants are the substances that you start with. In this case, sodium and chlorine yields. This arrow tells you that the reactants become the products through a chemical reaction. The products are the substances that are newly created. In this case, it is sodium chloride. Let's understand what are coefficient and subscript. Coefficient is the number before a chemical formula used for balancing the chemical equation. Subscript is the little number after an element in a chemical equation. These are the parts of a chemical equation to understand. How to write a chemical equation. Steps to be followed. 1. Identify reactants and products and place them in word equation. 2. Convert the chemical names into chemical formula and write the state symbols. 3. By writing the physical states of substances, a chemical equation becomes more informative. 4. Balancing the chemical equation. Let us understand each step in detail. Step 1. Identify reactants and products and place them in word equation. Example: magnesium plus oxygen gives magnesium oxide. The reactants are magnesium and oxygen, and the product formed is magnesium oxide. Step 2. Convert the chemical names into chemical formula and state the equation. Magnesium plus oxygen gives magnesium oxide from the example. Magnesium is a monoatomic, so it is written as Mg, whereas oxygen is diatomic, that is, free oxygen is present as two atoms of oxygen and always bonded together as an oxygen molecule. So it is written as O2, which gives the product MgO, that is magnesium oxide. Step 3. By writing the physical states of substances, a chemical equation becomes more informative. Mg, magnesium, is a solid, oxygen is gas, and magnesium oxide, which is a product formed by magnesium and oxygen, is also a solid. Solid state is written by symbol S, liquid state is represented by symbol L, gaseous state is represented by symbol G, aqueous solution is written by symbol AQ. Step 4. Balancing the chemical equation. In order to assure the law of conservation of mass, a chemical equation must be balanced. That is, the number of atoms belonging to different elements on both sides must be equal. In the reactant side and the product side, the number of elements should be equal. Then it will be a balanced equation. Here, this is not a balanced equation. Let's watch a video on balanced and unbalanced equation to understand better.
In the previous part of the video, we'd seen that hydrogen and oxygen react to form water. Let's talk about another chemical equation. Zinc reacts with sulfuric acid to give us zinc sulfate and hydrogen. Do you notice something interesting about these two equations? Okay, let's draw a table under the first equation. In the first column, we write the symbol of the elements that are involved in the equation. Then in the second column, we write the number of atoms in the reactants. And in the third, we write the number of atoms in the products. Which are the elements involved in the first equation? Just two elements. So we write H and O in the first column. Now for each of these elements, we need to find the number of atoms on the reactants side. The number of atoms of hydrogen is 2 and the number of atoms of oxygen is also 2. Now we move to the right hand side, which has the product. How many atoms of hydrogen exist in the product? 2, that's right. And how many atoms of oxygen? Just 1. For each element, we look at the numbers written in the second and the third column. For hydrogen, we see that the number of atoms on each side is equal. But for oxygen, we see that the number of atoms on the left is 2 and that on the right is just 1. Do you know what we call such an equation? Yes, unbalanced equation. If the number of atoms of each element on the reactant side is not equal to the number of atoms of the respective elements on the product side, then we say that the equation is unbalanced. Now, can you make a similar table for the equation on the right? Can you fill in the values in these cells? Okay, so did you make a list of the elements present in this equation? We have zinc, hydrogen, sulfur and oxygen. On the left, the number of atoms of zinc is 1 and that on the right is also 1. And similarly, we find out the remaining cells of these three elements. What do you observe? You notice that for each element, the number of atoms on the reactant side is equal to the number of atoms on the product side. And note my words. It's true for each of the elements involved in the equation. We call such a chemical equation a balanced equation. Now you know the difference between balanced and unbalanced chemical equations. But why is the unbalanced equation called so? Do you remember the law of conservation of mass? According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. So the total mass of elements present in the reactants must be equal to the total mass of elements in the products. In layman terms, the number of atoms of each element must be the same before and after the chemical reaction. Hence we say that the first chemical equation is unbalanced. Can we balance this equation though? Yes, we can balance an unbalanced chemical equation. How can we do that? We will see that next.
The law of conservation of mass states that matter is neither created nor destroyed, so we must have the same number and type of atoms after the chemical change as were present before the chemical change. Because of this law, we need to balance a chemical equation. In this example, the fire wood burnt should be equal to the ashes obtained. What is a balanced equation? A balanced equation is an equation for a chemical reaction in which the number of atoms for each element in the reaction and the total charge is the same for both the reactants and the products. It is also called balancing the equation or balancing the reaction, and which holds good the law of conservation of charge and mass. In this example, 2 mg plus oxygen gives 2 mgO. Now, this is a balanced equation. Here, we have added 2 mg atoms and oxygen as a free oxygen, which is diatomic, and the product what we obtained is 2 mgO, which is 2 magnesium oxide. Now, this is a balanced equation. Let's try solving or balancing the equations. The first example is zinc plus HCl gives zinc chloride plus hydrogen. We have put a table here as element, number of atoms in the reactant side and number of atoms in the product side, and whether it is a balanced or unbalanced equation. Now put all the elements, zinc, hydrogen and chlorine. Number of atoms in the reactant side is 1, 1 and 1. Number of atoms in the product side is zinc is 1, chlorine is 2 and hydrogen is also 2. Now check whether they are balanced or not. While we check each element, zinc is balanced whereas hydrogen and chlorine is not balanced because one atom is there in the reactant side and two atoms are there in the product side. So since this is not equal, it is an unbalanced equation. Now to balance this equation, zinc, hydrogen and chlorine must be balanced in the reactant side so as to get equal to the product side. To do that, we have to multiply coefficient as 2. If we multiply 2 for hydrogen and chlorine, it will be balanced in the reactant side. So, hydrogen chlorine will be equal to 2 2, same as in the product side. Now, this is a balanced equation because we have been multiplied with 2 as its coefficient. The reactant and product is equal now. Now, zinc plus 2HCl gives zinc chloride plus hydrogen. This is a balanced equation. The next example is Na plus Cl2 gives NaCl. The elements are sodium and chlorine. The number of atoms in reactant side, sodium is 1 and chlorine it is 2. Whereas in the product side it is 1 and 1. Here it is not a balanced equation because the number of atoms in the reactant side and the product side are not equal. So it is a unbalanced equation. Let us try to balance this equation. When we put coefficient as 2 for sodium, it becomes 2Na, and chlorine is as chlorine in the reactant side. The number of atoms in the product side, when we multiplied NaCl with 2 as the coefficient, it becomes a balanced equation. Here, the reactants and the product side, it is equal. 2 is equal to 2. So now it's a balanced equation. 2Na plus Cl2 gives 2NaCl. The third example is C5H12 plus O2 gives carbon dioxide plus water. This is not a balanced equation. The elements here are carbon, hydrogen, and oxygen. There are 5 carbons on the left but only one on the right. And on each side, the carbon is in a single chemical species. Put a 5 as coefficient in front of the carbon dioxide on the right hand side. Secondly, there are 12 hydrogens on the left but only 2 on the right hand side. And hydrogen is in a single species on each side. Now, when we put 6 in front of water on the right hand side, finally, there are only 2 oxygens on the left hand side but 16 of them on the right hand side. So when we put 8 in front of oxygen on the left hand side, we get balanced equation as C5H12 plus 8O2 gives 5 carbon dioxide plus 6H2O. Now it's a balanced chemical equation. The reactant side and the product side are balanced. Now let's watch a couple of videos on how to balance the equations in detail.
Hydrogen reacts with oxygen to form water. And we saw the reason why this chemical equation is unbalanced. The number of oxygen atoms on the left is not equal to the number of oxygen atoms on the right. The important question is, can we balance this equation? The answer is yes. Let's go step by step and see how we can balance it. As the first step, it's always a good idea to draw boxes around each element or compound, like this. Why did we draw these boxes? It's because nothing inside the boxes can be changed or altered when we are balancing the equation. You'll understand better soon. Next, we form a table like we've already drawn here. This row in the table tells us that the number of atoms of oxygen on the reactant side is not equal to that on the product side. It's 2 on the left and 1 on the right. So let's try balancing the oxygen atoms first. As there's 1 oxygen atom on the right and 2 on the left, we multiply H2O with 2. What we have here is a partially balanced equation. The number of oxygen atoms on the right is 2 and that on the left is also 2. Also remember that you cannot alter the formulae of compounds or elements involved in the reaction, which means that to balance the oxygen atoms, we cannot change H2O and write it as H2O2. This would be incorrect. Let's go back to the partially balanced equation. The number of oxygen atoms on each side is balanced now. But what about hydrogen? When we multiplied this compound with 2, what happened? The number of oxygen atoms were equal on each side, but what about hydrogen atoms? The number of hydrogen atoms on the right became 4. And what's the number of hydrogen atoms on the left? It's 2. So how do you think we can balance the hydrogen atoms now? We can multiply the hydrogen on the left-hand side with 2 to get this. Is the equation balanced now? Absolutely. We can form the table and verify it. This is what you'll get. So we simply multiply the appropriate elements or compounds as necessary to balance each and every element. When all elements are balanced, we say that the chemical equation is balanced. Easy, wasn't it? Why don't you try balancing this chemical equation? You'll see the solution in the next part of the lesson.
Now let's watch a couple of videos on how to balance the equations in detail.
This was the equation I had asked you to balance. What's the first step we can do? We draw boxes around each element or compound. The purpose of these boxes is to make sure that you don't change anything inside the boxes. Whatever you want to multiply, you do it to the entire box and not just one particular element. Next, we populate this table. In the first column, we write down the different elements involved in the reaction. And then in these two columns, we write the number of atoms each element has on each side of the equation. Why don't you try filling up this table? Which are the elements or atoms present in the equation? Iron, hydrogen, and oxygen, that's right. If you've not tried it yet, try filling up these two cells for each element. This is how the table would look. You see that iron and oxygen are not balanced in this equation. So the important question is, which atom should we start balancing first? Should it be iron or should it be oxygen? That's where the third step comes in. Look for the atom which is maximum in number on any side. If we look at this table, the maximum number is 4 and it's on the right. Oxygen in this compound has 4 atoms. So our first aim will be to balance the oxygen atoms. On the right, it's 4 and on the left, it's 1. So to balance the number of oxygen atoms, we multiply this compound with 4. So the number of oxygen atoms on each side is 4 now. This is a partly balanced chemical equation. But the iron and hydrogen atoms are not balanced now. When we multiplied this compound with 4, the number of hydrogen atoms on the left became 8 and that on the right is still 2. As the number of hydrogen atoms is 8, let's proceed with balancing the hydrogen atoms next. As it's 8 on the left and 2 on the right, we multiply the hydrogen on the right with 4. Is the equation balanced now? The number of oxygen atoms on each side is 4 and the number of hydrogen atoms on each side is 8. And what about iron atoms? It's 1 on the left and 3 on the right. So the equation is just partly balanced. So to equalize the Fe atoms, we multiply Fe on the left with 3. Is the equation balanced now? Yes, it is. The number of atoms of each element is equal on both sides of the equation. 3 of iron on each side, 8 of hydrogen on each side, and 4 of oxygen on each side. You'd have noticed that there are no fixed steps to balance a chemical equation. We just try balancing each atom at a time, which is why it's called a hit and trial method. We make trials to balance the equation. Though we've balanced the chemical equation, there's one additional thing we can do. We can write symbols of the physical states of each reactant and product. What do I mean by this? There are 4 main states of the reactants and products: gaseous, liquid, aqueous, and solid. We know these 3, but what's aqueous? The word aqueous is written if the reactant or product is present as a solution in water. So the balanced equation we got can be written like this. This clearly gives us more information about the equation or reaction. These 2 compounds are in solid state, and notice that G is written next to water. It means that water was used in the form of steam in this reaction. And sometimes there are conditions under which the reaction occurs. Conditions like temperature and pressure are written above or below the arrow. So if 2 reactants A and B react at 100 degrees Celsius to give C and D, it is written like this. If the reaction requires sunlight, it can be written like this. Would you like to balance a couple of chemical equations by yourself? Here you go. Tell us your answers in the comment section below.
Let's run through a quick recap on the topics learned in this video. What is a chemical equation? How to write a chemical equation? What is law of conservation? What is a balanced equation? A chemical equation is a mathematical representation which symbolizes the product formation from reactants. To write a chemical equation, first identify the reactants and products, convert to chemical formula, write the physical states of chemical equation, and balance the chemical equation. The law of conservation of mass states that mass cannot be created or destroyed in a chemical equation. The reactants and the products remain the same even after a chemical reaction has occurred. A balanced equation is an equation for a chemical reaction in which the number of atoms for each element in the reaction and the total charge is the same for both the reactants and the products. Okay, children, I hope you all understood the concepts in today's video, how to write a chemical equation and how to balance a chemical equation. If you have any doubt, please let us know. See you soon in the next video, part 3 of chemical equation. Bye.